Hi, good afternoon, everyone. So my name is Yoshinori Matsunobu. So I'm a MySQL tech lead at Facebook. So today I'm going to talk about how online backup works with MyRocks and RocksDB. So first of all, let me introduce about MyRocks. So MyRocks is a storage engine of the, on top of RocksDB. So RocksDB is a key value store, the log structured merge-based, LSM-based key value store, which was forked from a LabelDB. So LabelDB was created by Google, then Facebook forked and branded as a RocksDB for using in the backend. So MyRocks is a storage engine embedded with RocksDB. So the purpose is we had a huge amount of InnoDB-based MySQL applications, and we wanted to migrate to RocksDB without changing applications. So MyRocks can replicate from InnoDB, so it can technically easily migrate without rewriting applications. So that's why we created MyRocks, and which is open source in GitHub, and you can use from a Percona and MariaDB as well. And the background of the development of MyRocks was there are basically three constraints in the application side. So one is the read performance and write performance and the space. So you cannot optimize everything. So normally you pick one or two out of the three. So InnoDB and B-tree favors pretty much read at cost of write and space. But on the other hand, the MyRocks and the RocksDB and the general LSM databases like HBase favors space and writes, but the reads are slightly slower than B-tree database. So there are trade-offs. So this doesn't mean the InnoDB is inferior or MyRocks is better than any database. This is not true. So there are trade-offs. But at Facebook, so for large-scale databases running on Flash, then the saving space was very important. On the other hand, the Flash was very fast on reads, so read inefficiency can be mitigated by Flash to some extent. And we had a huge record cache at Facebook, so we can, cache hit rate absorbed the read request to the database. On the other hand, write inefficiencies it's a bit hard to mitigate because all writes are eventually coming to database. Other than that, so implementation also matters. So recently, my Facebook colleague published a new compression library called GSTD, G Standard, which is better than glib for almost all aspects. So it is new implementations, and implementation matters to some. For certain kind of libraries or databases. So these are the very rough matrix about the read and the space and write trade-offs. So InnoDB has a compressed and a compact format. So normally the uncompressed InnoDB is best on the read performance. The compressed InnoDB is slower on reads, but the space is significantly smaller compared to a compact InnoDB. And MyRocks is even smaller, like a 4 times smaller compared to a compact InnoDB, or 2 times smaller compared to a compressed InnoDB. And write efficiency is also better, but read performance is slightly worse compared to InnoDB. And the HBase was implementation is a bit inefficient, so it's pretty space was smaller, close to MyRocks, but read and write performance is worse than MyRocks. So current state at MyRocks at Facebook is so we created MyRocks for running on the Facebook. So we have two very large databases. One is called the UDB, which stores Facebook users, people's activity data, like or comments. So that database and the Facebook Messenger storing the Facebook messaging activities. So these two databases were migrated to MyRocks and running in production for more than a year. So InnoDB to MyRocks purpose was saving space. So this was the efficiency gains. And the HBase to MyRocks purpose was different. So space was almost the same because both are LSM, but the performance and reliability were much better with MyRocks. So these wins are huge for us. And we also started gradually working on the migrating a long tail, smaller databases services to MyRocks. So today I'm going to talk about the backups. So the backup has two parts. The one is a logical backup, which is MySQL dump, and the second part is a physical backup, like extra backup side. So the typical use cases of the logical backup is like preparing for disaster recoveries or the schema changes or migrations. So we take logical backup pretty often. So we take logical dump every day for just recovery purposes, and we sometimes do schema changes or data migrations. So these involve a logical backup. And the MySQL dump -- single transaction is the command to take a consistent read. And internally, it executes several key SQL statements. The most important ones are probably these two: the set session, transaction isolation level, repeatable read. So repeatable read means for the same transactions, it uses the same transaction snapshot. So all reads are consistent. And start transaction with consistent snapshot. But Facebook, and I think the Percon has this extension too, but it starts transactions with getting binary log state with consistent state, with pretty minimal overhead. So these two, by combining these two statements, the following select statements results are consistent for all of the transactions. And bin log state can be acquired with minimal overhead. So internally, it calls a RocksDB's API called getSnapshot. But the backup transactions may take very long time, so if there are tables are very large. So the common issues of the backups is the snapshot duration can be hours or even days, because of the backups can take a very long time, especially the database is very large, like terabytes orders. And the penalty of having a long-running snapshot can be very huge in the InnoDB. But it's more efficient in MyRocks. So let me explain the differences. So here's an example. So starting a transaction with consistent snapshot, and there's a table, but the transaction takes a very long time to taking backups from other tables. And on the other hand, there is a table and T, primary key equal 1 and value equal 0. And there are some other applications updating that value, incrementing a value equal value plus 1 for many times, like 1 times, twice, 3 times, and updating many times to like 1 million times. Then after 1 million times, then value becomes 1 million. But this backup client selecting from T, returning the value equal 0 for that primary key, because the transaction started before updating the table. So for this select statement work, the InnoDB is extremely expensive, but MyRocks is not much expensive. So let me explain the difference. So this is explaining how snapshot works in InnoDB. So InnoDB has the latest record here, but in the undo space, so there are all the record changes tracked. So from original value to 0 to 1, 2, 3, 4, 5, then blah, 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 up to 1 million. So InnoDB tracks the undo histories in the list. And to get the consistent state, these values, then it has to rewind the all list up to the updated time. So in this case, it's 1 million times, so which is very expensive, and it may take hours to just returning this single value. On the other hand, so MyRocks is much more efficient in this case. So in MyRocks and RocksDB, so all updates are first coming to in-memory structure called memtable. And when starting a transactions, then all the following the sequences, transaction updates to the same keys are tracked and are not removed like in a DB. So it's like, for example, if there are 1,000 entries, but when memtable gets full, typically it's a 164 megabyte or 128 megabytes, then another process called a flash happens. Then memtable's data was saved as a file called SSD file. Then during a flash period, the RocksDB knows that all intermediate sequence numbers are not needed. So RocksDB automatically discards them, then just writing the oldest sequence number and the newest sequence number. So it just stores 2 entries. And another compaction may happen, flash may happen, then another process called compaction happening to merging several SSD files into one. So during these steps, all intermediate SSD sequence numbers can be omitted away. So this means the only 2 entries are needed to handle workloads. So this is much smaller than 1 million updates in the tracking the 1 million histories in a DB. So this is much more efficient. So typically, MyRocks, when there is a long-running transactions, it can handle much better than in a DB. The feature we recently added was a parallel consistent dump from a same table or same database. So start transaction with shared RocksDB snapshot is a new syntax added in the Facebook MySQL. So this creating a snapshot and starting a transactions, but also it returns a snapshot ID that can be used in later other transactions. And we added another syntax called a start transaction with existing RocksDB snapshot, like snapshot IDs. So this syntax is starting transactions with a specified sequence numbers, snapshot IDs. So this means when executing this one, the first one and the second ones in different sessions, so these 2 transactions are using the same snapshot. This means all select results are consistent between the 2 result sessions. So, like for example, if there is a table 1, 2, 3, so large table T1, T2, T3, and starting a transaction with shared snapshot and another 2 clients, so using the start transaction with existing snapshot with the same snapshot IDs. So all these clients can run in parallel, and these results are consistent. So this means we can run the parallel backups, parallel consistent backup, which is a pretty big deal to if you need a consistent backup from a very large database. So another feature we are planning to add, so we have not supported yet, but we are planning to do is a consistent snapshot across multiple different instances. Like, as you know, the Facebook runs very many sharded MySQL databases, and sometimes we want to take a consistent read from multiple shards. So normally we couldn't do that with MySQL, but we are planning to add clock, the global logical clock, like a hybrid logical clock like HLC, in the RocksDB's sequence number or the binary logs, then starting a transactions with consistent snapshot based on the time. Then executing that transactions on the multiple shards. Then the result sets are based on that timestamp. Then the time is with implemented property that these timestamps can be consistent across multiple shards. This means you can take a consistent reads across multiple instances, and you can even take a consistent logical backup from multiple shards. So this is what we are planning to implement in the near future. The physical backup. So physical backup is not compared to logical dump. It's a binary backup. So typical use case at Facebook is taking a physical copy to creating a new replica. Like for example, when creating a new data centers, then we run the online backup to create copying the instance to remote destinations. And here's a step-by-step to take a physical backups online. So RocksDB has an API called a create checkpoint. So create checkpoint is a RocksDB API. So when using a checkpoint API, so RocksDB internally creates a hard link of the SSD, the data files, and the write-ahead log, which is a read log, and the manifest, which is a kind of a catalog database, the metadata files. Then putting to specified locations. So after calling the checkpoint APIs, then you can manually copy these SSD or write-ahead log and manifest files somewhere. This is basically a physical backup. So it internally involves flashing mem tables, which is a bit expensive, but it's lightweight enough, so it doesn't cause stalls. And MyRocks has a command called the set global, the RocksDB create checkpoint equals the directories. Then these operations can be automated. Here's a step to restore. So once you take a backup, so you copy the files, then you can copy into target servers, remote destinations. After copying the files, then starting the instance. After starting the instance, then MyRocks internally stores the bin log state and the replication state, like a binary log, and the replication state, like a master bin log file name or position on GTIDs. So by using these information, so you can figure out from which GTID position to start replication from a masters. So MyRocks stores all necessary information of the replica and replications, so you can configure GTIDs based on that. But the problem of this approach is, so the replication starting the timestamp is time of the creating a copy. So for example, if there is a 1 terabyte instance and you take 10 hours to copy the 1 terabyte instance, then replication will start from 10 hours old ago. So this means if the master doesn't retain the 10 hours of the binary logs, then replication cannot be started. So because necessary binary logs no longer exist. So we added a feature called renewing checkpoints. So by refreshing the checkpoints every intervals, like 20 minutes or so, then data can be relatively newer. So here's how it works. Like first creating a checkpoint, then starting a copy the SSD files. But when the data file is huge and only the SSD 0 and 3 could be copied, then creating a checkpoint again, then creating a checkpoint 2. Then new files like 5 and 6 were created. Then copying the differential files, like in this case, 4 and 5 and 6 are newly created. So starting a copy from 4 and 5, then repeating them, and creating a checkpoint multiple times. And in the last stage, copying all of the SSD files and the write-ahead log and the manifest files. So by repeating these steps, the replication can be started at the last checkpoint. So this means if the last checkpoint finished in the 10 minutes ago, then you can only need to apply the 10 minutes of the binary logs, so from the replica. So this means you can catch up replication very quickly. So MyRocks Hot Backup is an open source tool, so embedded is MyRocks. So this automates everything, so these steps, because these steps are pretty complicated, so we automated by the tool, so which is open source, and we are working with Percona to integrate to Excel backup, so it's in work in progress. So these are the basics, summary about how MyRocks and RocksDB handles the online backup. So MyRocks supports online logical backup with lower history lengths compared to InnoDB, because MyRocks and RocksDB can compact all intermediate unnecessary modification histories. This means the history list lengths can be a lot smaller than InnoDB. And we have plans to support a parallel consistent dump or cross-instance consistent snapshot trees, we are planning to do that. And the physical backup can be taken online as well, and the replication catch-up can be short by removing checkpoints. Yep. So thank you. That's all from my presentation. Any questions? Yes. Could you say it again? NVM snapshot? Okay. The question was if you can take an NVM snapshot. I think it's doable. So RocksDB's SSD files are immutable. So SSD files are immutable, but the write-ahead logs are mutable. So it's a bit complicated. But yeah, we don't use LVM, so we have not tested yet. But technically doing a very similar things. So RocksDB create checkpoint is creating hard links, so which is very close to creating a snapshot of the LVM. I don't know if there are some existing RocksDB users using a LVM snapshot, but I think it's doable. Okay, thank you.